Now we are going to solve question number 1.27, and in this question it is given to you, and actually my dear student, this is very important question, because till now whatever the question we have solved, it is having electric field that is constant, it is not varying with space, clear. But in this question we can say electric field is actually varying in a z direction, clear. So now concentrate. In a certain region of space, electric field lines is along z direction throughout, clear. So we can see, according to question, we can see electric field lines in z direction, clear. So we can say this is electric field direction. Let's suppose I am assuming here this is positive x, clear, this is positive y, and let's suppose this is positive z direction, clear to you. Okay, so electric field in positive z direction, the magnitude of electric field is however not constant but increases uniformly along positive z direction. It means we can say electric field is increasing in this direction. This is given to you, okay, at the rate of 10 to the power 5 Newton per coulomb per meter. It means here it is given dE by dz, clear. It is given to you 10 to the power 5 Newton per coulomb and per meter. This is given to you, okay, fine. What are the force and the torque experienced by a system having a total dipole moment in negative z direction? So if we are talking about dipole moment, so dipole moment means we can say in negative z direction, the direction of an electric dipole moment is given by minus q to plus q charge. It means we can observe here minus q charge we have here, and we can say this is plus q charge. Yes or no? Clear to you? And it is also given what are the force we have to calculate and torque we have to calculate. Okay, fine. Electric dipole moment, this is given 10 to the power minus 7 coulomb per meter. So we can say this is given by 10 to the power minus 7 coulomb meter, clear. So now listen carefully. Whenever we place an electric dipole that is having a distance 2a between them in an electric field, and important part we have, this electric field is not varying with electric field is actually varying with space. This is given to you because 10 to the power 5 Newton per coulomb per meter is given to you. Yes. So if we talk about electric field, so on this charge force is acting in this direction, this is F1, and on this we can say this is F2, clear. How can we write value of F1? F1 we can say this is equal to Q into E1, clear, and F2 we can say this is Q into E2. Direction we have already seen logically, clear. So value of Q we have Q, and let's suppose we are assuming, let's suppose I am assuming electric field is here 1 Newton per coulomb. I am assuming, actually it is not given in a question, I am assuming E1 equal to 1 Newton per coulomb. Now you can say how can you assume, because we will find here difference, because our objective in this question is to calculate net force on this dipole. So definitely this one will be cancelled out, clear. So how what is value of E2? Listen carefully. At this position we have electric field, this is 1 Newton per coulomb, and in this question it is given it increases at the rate of 10 to the power 5 Newton per coulomb. Yes or no? And per meter. So we can say here we are having distance, this is 2a, so we can say 2a multiply 10 to the power 5. Yes or no? Clear? Here we have electric field, let's suppose 1. Here it is increases 10 to the power 5 Newton per coulomb per meter. So we have total distance 2a, so it is increases by, we can say total electric field at position 2. We have this is 1 plus 2a into 10 to the power 5, clear. This is position number 1 and position number 2, clear. Now if you find here net force we can say this is Q of delta E, clear, or you can also write like this, this is equal to Q E2 minus Q E1. Yes or no? So we can say this is equal to Q E2. Value of E2 we have 1 plus this is 2a into 10 to the power 5 minus 1. Yes or no? Clear? So we can say 1 and 1 is cancelled out. Clear to you? So from here we can write like this, F net, this should be equal to Q into 2a into 10 to the power 5. Clear? Okay, Q into 2a means what? Q into 2A. This is what? Electric dipole moment? Yes. So we can say F net, this is given by P into 10 to the power 5. Clear? So from here we can write, how can we calculate net force? Value of F net, it is given by P into 10 to the power 5. P value is given 10 to the power minus 7. So 10 to the power minus 7 into 10 to the power 5. So from here we can say this is 10 to the power minus 2 Newton. Clear to everyone? Yes or no? So we have value of force 10 to the power minus 2 Newton. But what about torque? Now you can see actually both forces are acting along the same line. So we can say it will not form, it will actually not rotate this dipole. Yes or no? So final answer I can say net force we have 10 to the power minus 2 Newton. Clear? And direction definitely minus Q to plus Q. Clear? Because this force is more compared to this one. And net torque we can say this is 0. Clear? So this is all about this question. Clear?